Bonjour, welcome to Wahsa Distance Education's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live in today's lesson, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or through the television at Bell Express View channel 972. You're always welcome to join me through our Zoom link. You can get it through me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday at 11 to 12 in the morning, and we are now in week 5 of our 9-week course. We're halfway through our time, so you need to start submitting some work if you haven't already. What work to submit for marking? The ones marked with the pencil icon, the support questions, are not to be marked. They are just for practice for you. So you decide which ones to complete and how many to do. If you're understanding a concept, feel free to skip questions, spend your time on what you need to, and don't spend time on what you don't need to. You know that best. And if you need more practice, let me know and I can send you more questions. The answers are in the back of the booklet, so check your work to make sure you're on the right track. However, mistakes have been found, so if things are not lining up, if they're not making sense, let me know, and there may be errors that we need to correct. The key questions, those marked with the key icon, are the ones to submit for marking. So please do all of those questions and show all of your work, all of your steps and your thinking, so I can give you full credit for all that you understand. How to submit your work for marking? There are 3 different methods you can use. The first is to scan and send your work in electronically. Scan your completed works in through either the iPhone Notes app or the Android Google Drive app. You can also take a picture if that works better for you and send it as well. Scanning is just a smaller file and it might be a little bit easier. Then you can either email it to me at studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at our office at Front Street at our side entrance. We're the big red building next to the post office, and there's a small white box next to our side door. We're continuing to work remotely, so it may take me a couple of days to get it, but I'll mark it and get it back to you as soon as I can. Third method is to hand it into your DEC. Your DEC can then either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you have any questions or concerns, please contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE @nnec.on.ca. You can connect with me through Facebook at bslatewahsa. You can call and leave me a message at the main office. The number is 807-737-1488 or toll free 1-800-667-3703. I'll return your call as soon as I can. My office hours currently are Monday through Friday, 8 a.m. to 2 p.m. If you'd like to connect with me through social media, both my Facebook and my YouTube are named bslatewahsa. So feel free to friend me and subscribe to my YouTube channel. All of our radio Zoom classes are uploaded shortly after airing on YouTube, and I share them on Facebook, so you can access them there. There are also short videos explaining common errors or confusing concepts, things we don't have time to go through in our class because they're not part of our current curriculum, but are building blocks that you may need. So that's a great place to go and access things if you are struggling with something. Math is a very visual subject, so being able to connect to the videos is going to set you up for the most success. So please either join me through Zoom, through the live time, or access the YouTube videos on replay. If you don't have access to the internet or your internet's spotty and you'd like a copy of the videos, I can send you some on a USB key, so just let me know and I will send that up to you. We are on day 17 of our course, and we are doing the second part of lesson 11, trigonometric ratios. We're now looking at how to solve for angles, whereas our last class we solved for sides. So our learning goals are the same as our last class. Last class video, I'd suggest that maybe you want to start there. But you will be able to recognize and label the parts of a right triangle. You'll understand how to use trigonometric ratios to find unknown sides, and particularly interior angles of right triangles today. The success criteria, such that you can say, I can identify the opposite and adjacent sides as well as the hypotenuse side. I can solve for unknown sides using trig ratios, and I can solve for unknown angles using trig ratios. All right, let's activate our brain with some mental math. We talk about how mad minutes were not helpful, were not beneficial for most of us in terms of learning our arithmetic, learning our different operation strategies and such. So instead of doing those drill and kill mad minutes, we work on developing different strategies that we can use in different situations that make us comfortable with numbers. Today, we're going to be doing something that blew my mind when I first saw it, when I was first introduced to this strategy, and is a little bit tricky. If it confuses you and is not useful, then don't use it. All these are, you choose what works best for you. They're different ideas that could be great strategies for yourself. If something doesn't connect, then ignore it. Don't stress about it. Our question is 23 take away 15, but we're going to be using place value and negative numbers to do subtraction. There's a very common error that people make with subtraction all of the time. And this time we're going to look like we're making that error, but we're actually not, because we're going to make sure that we're using negative numbers. So often I'm going to do the mistake that people make all the time. So people often do, so if we have 23 take away 15, people often stack them and subtract the little number from the big number. So they would do 3 take away 5, and they would say that that's 2, because 5 take away 3 is 2. And then they would do 2 take away 1 is 1. So 23 take away 12 is, sorry, 23 take away 15 is 12. That is not correct. So this is a very, very common error. We're going to see doing something similar but different that gets us to the right answer. So instead, we're going to say, okay, well, 23 take away 15, we're going to say, okay, well, 20 take away 10 is 10. Okay, that is fine. And then we're going to say, okay, well, 3 take away 5 is actually -2, right? We still have a difference of 2, but now if you think about it, we're at 3 degrees and we take away 5 degrees. Now we're at -2. So what we can do with this is that we can say, okay, well, 10 take away 2 is 8. So that 3 take away 5 telling us -2 means that we still need to take away 2 away from our 10. And so 23 take away 15 is actually 8. Took me a while to sit with this and to make it make sense. So if it's something that you want to play with a little bit, feel free to have that. If you're subtracting and ending up with negative numbers, which then means you continue to subtract from the other numbers, the positive numbers that you have, play with it. It's something that's a little bit mind-boggling, but it's an interesting strategy that can be useful in some cases. All right, let's move on and not spend too much time subtracting. Our mind's on today, so engaging prior learning. We're still looking at triangles, we're still doing trig. So we need to remember that our interior angles, our angles on the inside of our triangle, always add up to 180 degrees. So our interior angles are what we generally think of as our angles of a triangle. We don't really think of the exterior angles, the angles on the outside, but our angles on the inside always add up to 180. Whether or not we have a right angle, which is 90 degrees, that is still going to mean that our triangle, so for this triangle, A plus angle B plus angle C is going to equal 180s. Or if we have a triangle that doesn't have a 90-degree angle, those are still going to add up to 180 degrees. Angle X, angle Y, angle Z are still going to add up to 180 degrees. So that's just something that we need to remember as we're moving forward. All right, let's explore some new concepts, which we're actually going to be doing some review of what we did yesterday as well, but we're going to be adding in a little bit more. So reminding you that trigonometric ratios are the ratios of any two sides of a right angled triangle in terms of the reference angle. So we have sine, cosine, and tangent ratios, and they can be used to find unknown sides and unknown angles. So we're going to start with the sine ratio, and we're going to go through again, which we did in our last class, what the sine ratio is, just to reinforce it because it is kind of confusing. So this is on page 2 of your IL book. So this is a repeat of what we did last class, but it's still important to remember. And so if we have a right angle triangle, the hypotenuse is always the longest side, which is across from the right angle. Any right angle triangle, hypotenuse is across from the right angle. And I label it HYP for hypotenuse, just the first 3 letters. Yes. The reference angle is the important angle in the situation in your question. In these questions, they always have to tell you what the reference angle is. You can't just pick, you have to know what the angle is that they're talking about. It is also never the right angle. It is always one of the other 2 angles in your triangle. So for our purposes, we're going to call the reference angle A, which means that for sine, the opposite side is always across opposite the reference angle. So we can find the side. If we draw an arrow across from our reference angle, that side that is across from it is our opposite side. And I label that OPP, the first 3 letters of the word opposite. So sine A is equal to the length of side opposite the angle A divided by the length of the hypotenuse side. So I say that sine A is equal to opposite over hypotenuse, and I write that as a short form as sine A equals OPP over HYP. That's how I remember it. If you'd like to use the acronym SOHCAHTOA, this would be the SAW part of SOHCAHTOA, which is just a phrase that people often use to help remember them. So S as in sine, O as in opposite, H as in hypotenuse, so that'd be the SAW part. I can't spell, so this never helped me, it just confused me more. But if that works for you, great. If just memorizing it as sine A equals opposite over hypotenuse, that works too. You figure out what works best for you. You choose. Okay, so then how do we find an angle? This is what we're doing that's new. So this is on page 6 of your IL book, and this is we didn't do in last class. We're still using sine, but now we're going to be looking at the angle, and that's different. So we have a triangle, a right angle triangle, with one side equaling 33, one side equaling 48 meters, and our reference angle is R in this case. So first we label our sides, and we see that the side opposite the reference angle is our 33 meter side. And our side that is our hypotenuse across from the right angle is our 48 meter side. So because we have our opposite, we know our opposite, we know our hypotenuse, that means that we're using our sine ratio because those are the 2 sides that we know. So sine R is equal to opposite over hypotenuse. So then we substitute in our values. Sine R equals 33 over 48. And we divide that. If we're going to write down that division, you need to use at least 4 decimal places in order to get an accurate answer. So sine R equals 0.6875. You can do more decimals, but really just the 4 decimal places is going to give you enough. If you do less than that, you're going to get an incorrect answer. It's really precise. You need to use the 4 decimal places. So then how do we figure out what that means in terms of our angle? Well, the old school method was to refer to trigonometric ratios where all the ratios were listed out. So here I have an example on my screen where I have all of our angles listed, angle 0, 1, 2, 3, 4, all the way up to angle 90. And then I have the sine, the ratio of the opposite side to the hypotenuse side listed as well. So this is how they used to do it before we all carried around scientific calculators. So what that means is how we would do it is that we'd say, okay, sine R is equal to 0.6875. So sine inverse, the opposite of sine, we would say, we look and we find as close of a number as we can to 0.6875. So on this chart, I can see 0.6820. So that's the closest value that I can find. And that tells me that happens when our angle is 43 degrees. So that means that our angle is approximately 43 degrees. And this is how, when I was in high school, we had to spend some time with these charts and finding things. We don't really spend time with those charts now. Now we just use our calculators. So let's see how we would do it with our calculator instead of using these charts, because the calculator holds all of this chart data in that information in its computer so that we don't have to look up these things. It just does the calculation for us. It just knows, it accesses these tables for us. So the notation that we use is sine to an exponent -1. We call it sine inverse, and that's how we that's how we do the inverse operation of sine in order to find what our angle is. So how we write that out is sine inverse, then open a bracket of sine r, close your bracket. So that's going to have your sine inverse is going to cancel off your sine and leave you just with r, is equal to sine inverse of open a bracket 0.6875, close a bracket. Is how you would write it down. So now we need to find our sine inverse button on our calculator. So our sine inverse, or sine -1, people sometimes call it, but I'll call it sine inverse, that's the technical term, is often the second function of the sine. I don't think I've ever seen anything else. So if you look at your calculator and you find your sine button that we were using for last class, then you find your second function. So there should be a button that gets used so that you have the writing that's above on your calculator. You press that button and then you press sine again, and now you're doing sine inverse. So we're going to look at calculator and do that for ourselves. So here on the Desmos calculator, it's a little bit different. So we see sine, cos, and tan here on the Desmos calculator. We don't have a second function. What they have here is that they say function. And so you click that, and then now you see that it has sine inverse here. So we click sine inverse, and then you need to go back to the main so that you have your numbers back, and 0.6875, and I missed a number, so I need to go back. 0.6875, sorry about that, is equal to 43.43. So we get even more precise. When we looked at the chart, we just got 43 degrees was our angle, but now we can get a more precise answer of 43.43 as our angle. I'm just going to quickly show you here for this example why we need to write those 4 decimal places if we're going to do it this way. So if I do the division, if I do sine inverse of 33 divided by 48, which is what our number was, if you look here, that's exactly the same. The number that we get through is 43.43253656, which is exactly the same as when we just wrote 0.6875. If I were to round my 0.6875 to something less, so if I do the sine inverse of that, so if I do 0.687, now I have 43.39. So that's already different just by rounding it to 3 decimal places. If I do sine inverse of 0.68, now I'm at 42.84. Again, I'm getting farther and farther away from my exact answer. And then if I just do sine inverse of 0.6, I end up with 36 degrees, 36.86. So it's really, you can see, if you don't do that 4 decimal places, you're going to really quickly get away from your correct answer, and that's going to impact your things. So it's really, really important if you're going to write down and not do the fraction, not do the division in your sine inverse, to do it at 4 decimal places. Okay, that was a little bit of interlude. So anyway, that's how you use your calculator to calculate these. So then we have our angle R. We have this little angle symbol, which is like kind of looks like a right angle triangle with the vertical line missing. Angle R is equal to 43.4 degrees. And that's how we find an angle for sine. As always, your calculator must be in degrees. If you notice in the Desmos calculator, here you can see here in the middle, it says GEG, it has degrees. If I were to change that, and now it says rad, if you notice, all of my numbers changed. All of my answers, because Desmos holds your information, you can see it changed all of them. So those are not anywhere near close to what we had in terms of our 43 degrees. So if you're doing radians, that's great, but we're not. We need to be in degrees. Our calculator must be in degrees. Desmos automatically leaves you in degrees, so you're probably not going to, as long as you don't click that button, you're fine. But you need to be paying attention to your calculator because that can be a mistake that's really going to cause you trouble. Okay, so that's all that's new in terms of sine compared to what we were doing in our last class. So if you want to pause the video now and do some practice problems on page 6, questions 5 to 7, those are the questions about finding angles with sine. All right, let's move forward with cosine, or cosine ratio. So again, this is on page 7 of your IL book. And we're going to remember what the cosine ratio means. So looking at a right angle triangle, the hypotenuse still is always the longest side, which is across from the right angle. Always your hypotenuse. I know that I'm repeating the same thing over and over again, but it's so important to do it correctly. Your reference angle is the important angle in the situation, and it is never your right angle. It is always one of the other two angles, and you have to know it. Now we're talking about the adjacent side, and the adjacent is always next to or adjacent to the reference angle. And I label it ADJ, the first 3 letters of the word adjacent. So our cosine is the length of the side adjacent angle A divided by the length of the hypotenuse side. So cosine equals adjacent over hypotenuse. And as a short form, I write that as cosine, COS for cosine, equals adjacent ADJ over HYP hypotenuse. Some folks like to use for SOHCAHTOA, like to use this as the ka part. So C for cosine, A for adjacent, H for hypotenuse. Again, either way, whatever you figure out how you remember it, what works best for you. Okay, so how do we find an angle? So we're going to be looking at this triangle. We have a right angle triangle. We're going to solve for our angle B. We have a side that is 37.2 centimeters and a side that is 85.9 centimeters. And there's a question like this on page 10 of your IL book. So we label our sides. We look at our reference angle and we see that the adjacent side is 37.2. And we see that our hypotenuse across from our right angle is 85.9 centimeters. So we have our adjacent and our hypotenuse. That means that we're using cosine. So cosine of B is equal to ADJ, adjacent over hypotenuse. We fill in our values. Cosine B is equal to 37.2 divided by 85.9. Again, if we're going to divide the 37.2 by 85.9 and write it down, that's going to be cosine B equals 0.4331. We're going to have 4 decimal places because the same thing applies in terms of it's more accurate. And then how do we find out if our cosine, our ratio of B is 0.4331? How do we find out what our angle is, how big our angle is? So again, we have trigonometric tables, which we could look it up. So our cos inverse of 0.4331, we would look at a cosine table. So this, you can see our angles are still listed from 0 to 90, but our cosine, you can see that our numbers are now different because our cosine, our ratio of our adjacent to our hypotenuse, is going to be different than our ratio of our opposite to our hypotenuse. So we look and we find where's our value, what value is closest to 0.4331. So we find that and we say, okay, so if that's, we have 0.4384. And so that means that our angle, when that happens, is angle 64. So our angle is approximately 64 degrees. Again, if we want to be more precise, we can use our calculator, which is what we're all going to be doing. We're not going to be looking at trig tables, but just so you understand where it's coming from. So if we're writing this down, we write down cos inverse, so cos to the exponent -1, open a bracket of cos b, close a bracket, equals cos inverse, which is cos of -1, to open a bracket 0.4331, close a bracket. And that's what we put in our calculator. So our calculator button for cosine inverse, again, is the second function of cos. So finding the cos, which is going to be right next to your sine button on your calculator, then doing your second function and finding and pressing cos is going to give you your cos inverse. Again, some calculators, you need to put your number in first and then press the button, the cos or cos inverse button. Some calculators, you need to your cos inverse first and then put your number in. You have to figure out what works best for your calculator. If you can't find the buttons or you're struggling with it in terms of figuring out how to get the correct answer, let me know and we can work through it for your particular calculator. So again, looking at doing this example on the calculator, on Desmos calculator. So we go to function, get cos inverse, and then we put in our 0.4331, and that equals 64.33. So 64 is what we found on the chart. Now we know that 64.33 is a little bit more precise. So our angle B is 64.3 degrees. And that's how we find an angle using a situation when we use our cosine ratio. As always, your calculator must be, I know I'm a little bit like a broken record for this lesson because everything is basically the same with slight adjustments, but I want to make sure I drive those points home. Okay, if you want to pause the video and do some practice on page 11 of questions 12 to 14 are going to give you practice with cosine and finding angles. And finally, let's look at the tangent ratio. So our tangent ratio is on page 12 of your IL book. And tangent is looking at our right angle triangles. Our reference angle is still, we need to know, an important angle that's not the right angle. So we have reference angle A. And for a tangent, we're looking at the opposite, which is always across from our reference angle. It's always opposite our reference angle. And then our adjacent, which is always next to or adjacent to the reference angle. We label those OPP, op, or ADJ, adjacent, however you want to label them. That makes sense for you. And our tangent, our tan A, is equal to the length of side opposite angle A divided by the length of the side adjacent angle A. So tan is equal to opposite over adjacent. I write that as tan A equals OPP opposite over ADJ adjacent. And this is your TOA if you're using SOHCAHTOA. So this is T for tan, O for opposite, A for adjacent. As always, you figure out what makes the most sense and what is easiest for you to remember. All right, so then how do we find an angle when we are using this information? So we have a triangle, right angle triangle, solving for M, angle M. We have a side that is 30 centimeters and a side that is 19 centimeters. So we need to label our triangle. So we see our side opposite our right reference angle, angle M, is a 30 centimeter side. And our side adjacent to our angle M is our 19 centimeter side. So because we have our opposite and adjacent, we have tan M is equal to opposite over adjacent, which is equal to tan M is equal to 33 over 19. Sorry, that should be 30. It's an error. I made a mistake. So I'm just going to do a quick check to see if where I made my mistake so that we know which one to correct. So 33 divided by 19 is 1.67. So I'm just going to change my side length here to my opposite side length. We're just going to say is 33 because that's the calculation that I used. Sorry about that. Okay, so my opposite side is 33. So divided by 19, my adjacent side. And I have, therefore my tan is equal to 1.736 8. In this case, tan, we have 1. It's greater than 0. It's greater than 1. So we have 1 point something, we still need to have 4 decimal places after the decimal point. Even though we have a digit other than 0 at the beginning, we still need to have 4 decimal places. Okay, so could go to our trigonometric tables. We have our tan table. You'll see our angles again are from 0 to 90. And our tan, you can see, has all of our different ratios. They increase. So for tan -1, tan inverse of 1.7368, we find that value in our table. We have 1.7321, that's pretty close. And that would give us an angle of 60 degrees. So tan -1, tan inverse of 1.7368 is equal to approximately 60 degrees. So again, how do we use our calculator to find that? We have tan inverse, how we write it is tan inverse, open a bracket of tan M, close a bracket. That's how we cancel off the tan, right? Leaving us with angle M is equal to tan inverse of 1.7368. So using our calculator is tan inverse is the same pattern. So it's going to be the second function of our tan button. And if we are going to go on Desmos to find that, so we're going to do this example. We have tan inverse of 1.7368 equals 60.06. So if we write that to 1 decimal place, that's going to be angle M is equal to 60.1 degrees. There we go. As always, our calculator must be in degrees. That's because we can say 60.1 degrees, our calculator has to be in degrees. We would say something different if we were looking for radians, and we don't do that in this course. All right, so again, if you'd like to pause the video and do some support questions, page 16, questions 19 through 21 are what we just helped with, and we should be good to go. So again, which ratio do I use? This is the most important question. How do we know if we're doing sine, cosine, or tan? All the steps are basically the same, but which ratio do we use is how we have to figure out. That's the hard part. Doing the steps afterward isn't necessarily that hard, as long as we're pressing the right ones on our calculator and it's in degrees, but knowing if we're doing sine, cosine, and tan, that's the part that we need to figure out first. So the ratio is decided by the information in the question. That's how we know what to use. So we have those steps, the same steps that we did yesterday on the previous lesson are still apply here, just that we're going to end up finding the angle instead of a side. So step 1, confirm the triangle is a right angle triangle. Yes, in our example, we have a right angle triangle. Step 2, label the sides of your triangle. And remember, we label all 3 sides. So we find our reference angle, and then we say, okay, this is our opposite is across from our reference angle. Our adjacent is beside our reference angle, and our hypotenuse is across from our right angle. So we label all 3 of our sides so that we can figure out what we know and what we don't know. Then step 3 is figuring out what you know and what you're solving for, what you don't know. So for our example, we have our adjacent side, we have our hypotenuse side, and we're looking for our reference angle that we don't know. So we can ignore our opposite side because we don't have any information and we're not looking for it. So then we need to pick ratio. So we have our 3 ratios. Sine B is opposite over hypotenuse, cosine B is adjacent over hypotenuse, and tan B is opposite over adjacent. So we have our adjacent and our hypotenuse. That means that we're going to be looking at cosine B, which is equal to adjacent over hypotenuse. That's going to be the ratio that we need to use for this question to solve for our angle. So following these 4 steps should set you up for success in order to figure out which ratio you have. All right, so let's consolidate this and then let's do some practice. So these are our highlights from lesson 11, both today and our previous one, because all of that's wrapped up into this lesson. So our trigonometric ratios, our sine, cosine, and tangent. And so we know that labeling the right angle triangle is essential. It's how we figure it out. So then using SOHCAHTOA, or sine A is equal to opposite over hypotenuse. So our cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. And then now we can solve for an unknown side based on using the ratios in algebra, or we can solve for an unknown angle based on using those ratios and using the inverse function on our calculators. And the ever-present reminder that your calculator must be in degrees in order to be successful for these questions. Success criteria, our first was that we can identify the opposite, adjacent, as well as the hypotenuse side, hopefully with lots of practice yesterday and going over it again today, you're comfortable with that. 2 is that you can solve for an unknown side, which is what we did yesterday. And then 3, we can now solve for unknown angles using the trig ratios and our inverse function. Hopefully you're now comfortable with that today. All right, so let's do some practice. So practice question, so number 1, it's asking us to calculate, and we have a tan inverse of 5.9328. So we're going to use our calculator. You don't have to worry about using the trig tables. Those were just to give you a context of where that information came from. Oops. Okay, so we're going to use our calculator. So we have tan inverse of 5.9328 is equal to 80.4. We can just do 1 decimal place is fine. So how we write that would be, we're just being asked to calculate it. So we would write that equals, we don't even have an angle. Don't even remember in that quick moment that I close it, 80.4 degrees. And that's all you need to do for that question. It's just practicing using your calculator. Okay, so then B, sine inverse of 0.4271. So again, let's get a calculator. So we have sine inverse. You'll notice that you might end up getting errors sometime on your calculator because you've made a mistake typing something in, you've pressed sine instead of sine inverse. So it's good to pay attention to those errors and then try again. So sine inverse of 0.4271 is 25.28, so 25.3 degrees. And then our part C, cosine inverse of 0.0256. So looking at our calculator, cosine inverse of 0.0256 is equal to 88.53, so 88.5 degrees. That's all we do. So it's really important to make sure that you're pressing the right ratio because you're going to get different answers depending on what your ratio is. All right, let's look at the next question. So here we have question 2, calculate angle n to the nearest degree. So we have sine n equals 0.5922. So how we would write this out to solve for this is that we have sine inverse of sine n. So I'm writing sine inverse, open a bracket, sine n, close a bracket, equals sine inverse, so sine to exponent -1 of, open a bracket, 0.5922. And again, we need to use our calculator. So we're doing sine inverse. .5922 is equal to 36.1, sorry, 36.31. So it's 36.3. So then how we write our solution is that we write angle n equals 36.1 degree. That's how we write it. So our next question, B, is cosine n equals 9 divided by 13. So again, we would do cos -1 of cos 9 divided by 13. We could leave it as a fraction and do the division when we are doing, I'm writing this wrong, sorry. Okay, well, let's start that again. So we have cos inverse of cos n, right? We're doing our angle is equal to cos inverse of n of 9 divided by 13. So angle n is going to equal to, and now we use our calculator. What I was saying before I realized I was messing up my writing, is that you can just do the division when you're doing in your calculator. So you can do cos inverse, and then you can do 9 divided by 13. You just have to make sure that your calculator is calculating it properly in terms of doing its order operations. So you might need to put 9 divided by 13 in brackets in order to make sure that you're doing cos inverse of 9 divided by 13, opposed to cos inverse of 9 and all of that divided by 13. That won't work. So our angle n is then equal to 46.2 for that question. And then finally, we have tan n is equal to 35 over 29. So why don't we do it the other way this time? So we're going to do tan of n, and we're going to do the division first. I'm just going to do that quickly. 35 divided by 29 is equal to 1.2069. And then now we would do tan inverse of tan n is equal to tan inverse of 1.2069. And then therefore angle n is equal to, using our calculator, we have tan inverse of 1.2069 is equal to 50.35, so 50.4 degrees. And there we go. All right. Question 4, calculate angle F. So we have a triangle, a right angle triangle that has a reference angle of F. And then we have one side labeled 12.1 and one side labeled 8.4. And we need to figure out what ratio we're going to use and then solve for angle F. So I'm going to look at my reference angle I know is my angle F. And so I'm going to think, okay, what's opposite? What's across from that? That's my 8.4 side. So that's my opposite. What is my side that is adjacent to my angle F? Is my 12.1. And then I always just label all three sides. So my side that is across from my right angle is my hypotenuse, just to make sure that I know what I'm doing. So in this, I've done step 1, it's right angle. Step 2, labeled my side. Step 3, what do I know and what don't I know? So I know my opposite and my adjacent, and I'm finding my reference angle. So opposite and adjacent is tan. So I don't need the hypotenuse. And so tan of F is equal to my opposite divided by my adjacent. So that's what I figured out my ratio. So then to solve for F, I do tan of F is equal to 8.4 divided by 12.1. So I'm just going to do it all one step in my calculator. So tan inverse, and as you can see, you can do both. You can switch back and forth. Of tan F is equal to tan inverse of 8.4 divided by 12.1. So get my calculator out. And I have, so tan inverse of 8.4 divided by 12.1. This is why I like the Desmos calculator, is because we can see that how they've written it is the same as how I've written it. So it's doing exactly what I intend. So then I get my angle F is 34.76, so 34.8 degrees. So angle F equals 34.8 degrees. And that's how we find which ratio to use so that we can find our angle. All right, so now question 5, calculate Y. So we have a right angle triangle. We have an angle of 28 degrees. We have a side labeled Y, and we have a side labeled 173. So let's follow our steps. Step 1, do we have a right angle? Yes, we do. We're good to go. Step 2, label our sides. Well, I only have one side labeled, so I'm going to assume is my reference angle. That's the side that I have information about. So my angle that's 28, even though I don't have a letter for it, is my reference angle. So across from my angle 28 is opposite, so that's my side Y. And adjacent my reference angle, I don't have any information, but I'm going to still label it adjacent. And then across from my right angle is my hypotenuse, which is my 173. So in this case, I'm looking for my opposite, and I know my hypotenuse. So opposite over hypotenuse is sine. So I say sine, I don't have an angle, so I'm just going to say 28. I don't have a letter. Sine 28 is equal to opposite over hypotenuse. You could just jump in and put your numbers. I like putting the opposite over hypotenuse to communicate that I know it, but also to help me remember. And then I can find mistakes if I make mistakes like I did in my previous lesson. So sine 28 equals Y over 173. So then in order to isolate for a Y, we need to multiply both sides by 173 in order to cancel off. So 173 times sine 28 is equal to Y divided by 173 times 173. So the 173's cancel off and leave me just with Y. And so I have 173 times sine 28. As you can see, this time we're not solving for an angle. We know our angle. We're solving for a side. But really, we follow the same steps. And it's just now that when we're doing our calculator that it really matters. So we go to our calculator and we do 173 times. And this time we're doing sine. We're not doing sine inverse because we're solving for a side. We know our angle. So we do sine 28. And that equals 81.2. So our side Y equals 81.2. So being able to do your questions that have, you know your angle, or you don't know your angle, or you know your sides, or you don't know your sides, they're not that different in terms of the setup. It's more just the calculations at the very end that potentially that's going to be different. So that's where you need to be paying attention and then making sure that you know what you're talking about. Am I talking about an angle? No. In this question, I'm looking for a side. So I don't have degrees. If I had units, I would say centimeters or meters, but I'm talking about a side. So 81.2 makes sense in terms of my side. All right, let's do a word problem. So we have number 6. Caleb uses a wheelchair. The ADA guidelines suggest that a safe, accessible ramp doesn't have an incline greater than 5 degrees. Caleb wants to enter a store that has a ramp that is 6.1 meters long and has a rise of 0.45 meters. Is this store accessible? So with these questions, whenever you have a word problem, if you don't have a diagram, I would suggest drawing a diagram to make sure that you know what it is they're talking about. So if we think about a ramp to a store, so we have our store, we have our ramp. It is completely fine if your drawing is not perfect in any way. Mine is not perfect in any way, but I'm getting the idea. I'm just visualizing it. We assume with buildings and construction that things are built at a right angle. That's the safe way. So we assume that our building is at a right angle to the ground, so that on our ramp is going to be a right angle triangle. If it's not, it's going to tell you differently than that in the question, but that's what we assume, because that is the premise of construction, is that we are building things at right angles. That's the sturdiest, so that things aren't leaning and falling. So we have our ramp as our right angle triangle. It says that it is 6.1 meters long. So we label 6.1 meters. And that it has a rise of 0.45 meters. So it goes up 0.45 meters. So it's also really important when you're drawing, when you're doing these questions, if you draw your image and you label it, that I know what you're basing your question on and I understand where you made a mistake. So then our angle of reference, so the angle from the ground up, is the angle that we're looking for to figure out if that is greater than or less than 5 degrees in order to make this ramp accessible. So we're just going to label that angle A so that we know what we're talking about. So we have our picture, we know it's a right angle, and we're now going to label our sides. So the angle across from our angle A is our opposite. That's our 0.45. Our angle adjacent would be the ground, which we don't have any information about. And our angle across from our right angle, our side across from our right angle is our hypotenuse, which is our length of our ramp, which is 6.1 meters. So we have our opposite and our hypotenuse. So that means that we're doing sine. So sine of A is equal to opposite over hypotenuse. There's not that many options. So you'll end up noticing that you feel like you're doing it over and over again because you are. There's only three. There are only three choices for you to do at this point. So sine of A is what we're trying to solve for. Try to find the angle, right? So opposite is 0.45 divided by hypotenuse, which is 6.1. So then the sine inverse, we're finding an angle. So we're going to do sine inverse of sine A is equal to sine inverse 0.45 divided by 6.1, which means that angle A equals, and now we're going to use our calculator. So we have sine inverse. So we need to get our inverse, right? Make sure we're pressing the right button. And then we have 0.45 divided by 6.1 equals 4.2. So 4.2 is what our angle is, 4.2 degrees. So now we have to see how we answer the question. Well, the answer to the question is this store accessible? That's what the question is. Well, 4.2 doesn't answer that question. I don't know. I have to interpret it. So an accessible ramp doesn't have an incline greater than 5 degrees. So is our incline, is our angle greater than 5 degrees? No, it's 4.2 degrees. So therefore, this store is accessible, which answers the question. And you could continue to say because your angle is 4.2 degrees, which is less than 5 degrees, or you could just write that the store is accessible, and that would answer the question, and I can see the reason, your reasoning why. If you just tell me that this store is accessible and you don't do any of the math, I'm going to say, how do you justify that? How can you prove that? If you do the math and then just write the sentence, I'm going to be able to see how you justify it. You probably should say because the angle is 4.2 degrees, which is less than 5 degrees, but if you don't want to, that's fine too. You just got to make sure you show me the math so I know where your answer is coming from. All right, so we don't have time to do our last, but again, here we have a problem with a bunch of words. We don't have a picture, so please draw your picture. It's going to help set you up for success for your question, and then make sure you're answering your question. But you can still use the 4 steps in terms of figuring out which ratio you're going to use. As always, if you have any questions, please contact me. This is what I'm here for. This is the whole point of my job, is to help you. So you can call me at the office and leave a message and I'll return it at 807-737-1488 or toll free 1-800-667-3703. You can email me at bronwyn.slate, which is BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at bslate Wahsa. I've connected with some other students and we do really well communicating in terms of helping. That's worked really well, so feel free to do that. And you can go to my YouTube channel at bslate Wahsa and find this video later this afternoon. And then you can slow things down or pause things and go back to things to help you understand as you go along. I hope you have a lovely day. Thank you for joining me. Miigwech.